Good evening good evening, good morning, good afternoon, depending on when you're listening to us. And this is CometWatch. My name is Nicky Vetts.
And I'm Neil Norman.
And first of all, just to quickly kick off, we're going to quickly go through some current comet magnitudes for March the 3rd and the observable region. So I'll start off with our favourite of everybody's at the moment, Lovejoy 2014 Q2. That's magnitude 5.5. It's fading and it's observable 80 degrees north to 5 degrees south. It's visible all night, and the last visual observation was in March 2015.
Next up is 88P Howell, which is magnitude 10.5 and brightening. It's observable from 30 degrees north to 65 degrees south, visible in the morning, and was last seen in March 2015.
Swan 2015 C2, magnitude 10.5, it's bright, 30 degrees north to 65 degrees south. It's a morning object and was last observed, in fact, it has not yet been observed in the Northern Hemisphere.
That's right. And next up is Catalina 2013 US 10, magnitude 11.5 and brightening. It's currently in conjunction with the Sun and was last seen in November of 2014.
And of course, then it's 15P Finley, magnitude 12, fading, 80 degrees north to 25 degrees south. It's an evening object and was last observed in February of 2015.
Next up is Siding Spring 2013 A1, currently magnitude 12 and is steady, 80 degrees north to 25 degrees south. Best seen in the morning and was last observed in November of last year.
Pan-STARRS 2012 K1, 12.5 degrees, magnitude 12.5. It's fading. Port elongation, last seen December 2014.
Next is Comet Borisov 2014 R1, magnitude 13, but fading. 45 degrees north to 60 degrees south. Best seen in the morning and was last observed in November of last year.
And next is Okomedian 2013 V5, 13 magnitude, fading. 70 degrees north to 45 degrees south. It's a morning object. Last observed in October 2014.
Next is 29P Schwarzmann-Wachmann, magnitude 13, question mark. It varies. 25 degrees north to 70 degrees south. Best seen in the morning and was last observed in October of 2014.
Pan-STARRS 2012 F3, 13.5, question mark, steady. 30 degrees north to 50 degrees south. It's a morning object, last observed May 2014.
Next is 32P Comus Solar, magnitude 14, but fading. 70 degrees north to 30 degrees south. Best viewed in the morning and was last observed November 2014.
And finally, Pan-STARRS 2014 Q1, magnitude 14, question mark. It's a bright comet. It's in conjunction right now and has not yet been observed. And if you want to get more information on these comets, please go to the British Astronomical Association Comet Section website, and they'll also give you other links to other comet pages. Now, we have a very special guest today, don't we, Neil?
We certainly do, Nick. Yes, we do.
Would our guest like to introduce himself, please?
Oh, you're gonna make me introduce myself, huh? Those people probably remember a bright comet from back in the late 1990s, bright comet called Hale-Bopp, and I'm the first half of that. Alan Hale.
Welcome to the show, Alan. Thank you for joining us. Can we ask you, how do you look for comets?
I don't. I mean, if you're referring to hunting for new ones, the answer is I don't. I did for a while, back in especially during the late 1980s, early 1990s. I had a comet hunting program going on for a while, and I was never successful, so I stopped. And then I found Hale-Bopp accidentally about 3 years later. So I guess my technique is hunting comets by accident. You hunt for comets by not looking for them.
Well, that's definitely an interesting way to do things. Now, what kind of equipment do you use when you're looking for comets by accidental discovery process?
I have a 16-inch or 41 centimeter, whatever language you speak, Newtonian reflector that I've had now for over 25 years now, and I use that instrument a lot for visual comet observing. and the night that the Hale Bob was found, I was looking at just some deep sky objects while passing the time.
Have you? You said you're a visual observer, so you prefer to use the Mark I eyeball, so to speak, in preference to electronic devices. Is there any particular reason for that, or is it just the way you prefer to work?
It's just a personal preference. I do have a CCD system, or at least I'd probably better use the past tense there. I did have one. The cameras are old. The telescopes that I would use them with, they have gear problems right now, and I just haven't been motivated to get those issues fixed. I would probably at least need to upgrade the camera. Those things do get kind of expensive, and although I guess I have the resources available now that I could, I just don't feel the motivation to do so. There's always been something kind of pleasant with me with actually encountering the photons with my own eyeball.
Yeah.
And that's why I tended to the visual work, which I've been doing now for over 45 years.
Neil, you got any questions, Neil?
Yeah, I just want to ask Alan how he felt when he knew that the comet that he discovered was going to be something very, very special indeed.
Well, it was, keep in mind, when I found the thing, it was only about 11th magnitude. It was pretty dim. And there was no real reason at that time to suspect anything unusual. In fact, my initial impression that this was probably a new shorter period comet, since it was near the ecliptic and moving roughly parallel to the ecliptic. And it wasn't until the first orbital calculations started coming out a week or so later that indicated that this was a long period comet far out, coming in for a fairly close approach in the inner solar system. And at that, it almost seemed unreal at that time. I mean, this was the comet that everybody wants to find. And so happens I stumbled across it. And countering that, though, was the knowledge that even though the orbit was starting to get nailed down fairly quickly, comets have a tendency to be rather unpredictable. And just because it had the potential to become bright doesn't necessarily mean that it actually would. So we had to wait until it actually arrived in the inner solar system before we really knew that it was going to be bright. So there was that long period of expectation. Although as time started to go by and the comet continued to behave itself, it began to seem more and more likely that, yes, indeed, this thing would become rather remarkable, and of course it did.
Certainly did, didn't it? Yeah, I mean, it was a record 18 months naked eye, I believe, and it's still held today, isn't it? So it's unbelievable, absolutely unbelievable. Must have been a huge comet as well, nucleus size. It must have been, I've heard people say it's up to 80 kilometers in diameter, but, it must have been getting along that sort of size, mustn't it?
Right. Yeah, it was clearly, in terms of actual physical size, certainly one of the larger, if not one of the largest, comets that have come into the inner solar system. And we know it's been around once before. The orbit that it came in on indicated that it's been around at least once before, a few thousand years ago. How many times before that, there's no way of knowing. Probably not very many, though. And,
no, that's right. I read somewhere that it...
Go ahead.
Sorry, carry on.
No, go ahead.
Oh yeah, no. Sorry, I was just going to say that I read somewhere that they thought it nearly collided with Jupiter in 2215 BC, wasn't it, or something like that, and it encountered Jupiter again on its last pass, which shortened the period this time round, didn't it?
Right. It passed about 0.75 AU from Jupiter on its way in. The ascending node of its orbit is very close to Jupiter's orbit. The descending node of its orbit is very close to Earth's orbit. So in future returns, we're looking at both a potential Jupiter impactor and a potential Earth impactor, for that matter, as well. So,
wow, I don't want to be hit by that. So, Nick?
Yeah.
Alan, what was your feelings when Shoemaker-Levy 9 actually impacted on Jupiter?
I don't know if I had any real feelings one way or the other. Certainly a very fascinating event. I know the Shoemakers, and I know David Levy. They're both friends of mine. David and I, in fact, have been friends for a long time. It was nice to see the publicity that they were getting. This was certainly a very unique event. Although I think as time has gone by, we're seeing that perhaps it was not as unique an event as we initially thought. There was the big black spot we saw in Jupiter's atmosphere about 5 years ago, which was obviously some other kind of impacting object. So the whole thing with Shoemaker-Levy was that it really brought home to us the fact that there are still objects out there and they're still impacting planets. I mean, here we had a chance, we saw it happen in real time. And that brought things from the realm of, well, this could happen, to the realm of, yes, it does happen. It created awareness, I think, was a very major deal.
I have to agree with that because, as I say, I remember when it started going down. In fact, I was actually permitted to use my company's then internet system, etc., to actually watch the whole thing live. And I must admit, for me, I would say it was interesting in the fact that here was a chance not only to see the interaction with a comet hitting the atmosphere, but also perhaps try and learn something more about Jupiter itself. And I know that the Hubble was involved on it, and even when the Weasley impact happened, although the Hubble was still being worked back up, it was certainly we must have it on this right now. So I think, yes, with Shoemaker-Levy 9 and certainly the Weasley impact, it has brought all this to the fore, and it's made the search and tracking of these objects much more important. How do you feel, I'm trying to put it away, as a home-based astronomer, about amateurs finding comets and recording and getting their discoveries noted and recognised?
Well, there's been obviously a significant change in all that within the last number of years, especially once the comprehensive survey started coming online in the late 1990s. The first major such survey was the Linear program, actually based very close to where I live. The Linear is based at White Sands Missile Range in south central New Mexico. In fact, I live less than a 3 hours drive from a Linear site. And I think once Linear started coming online, started discovering comets left and right. Of course, even though Linear itself is no longer operating, we've got survey programs like the Catalina survey and its affiliate programs based in Arizona, the Pan-STARRS program based in Hawaii. And they're finding the vast majority of comets now a long time before, even the ones that become bright are discovered when they're still very faint. You mentioned during your earlier list the comet Pan-STARRS 2014 Q1, which has potential to be somewhat bright this summer. And, of course, it was discovered last summer by the Pan-STARRS program when it was still 17th, 18th, 19th magnitude. And so right now, the image that we might have of the backyard person hunting for comets, that era seems to, if it's not already over, it's very close to being over. The last visually discovered comet was found over 4.5 years ago. Now, there have been several observers who have been successful discovering comets with CCDs. Terry Lovejoy, for example, has been very successful with that. I mean, he's found a total of 5 comets with either DSLR cameras or CCDs, including the bright comet Lovejoy that's in the sky right now. Gennady Borisov in Ukraine just found his 5th comet just within the last 3 weeks or so. He's actually searching for comets with CCDs at very small elongations at 60, and he found this last one at 16th or 17th magnitude, which, of course, a visual person could not even think of reaching. So there's still obviously room for amateur/non-professional. There's a gray area there. People finding comets, but even then, it seems like you need to be able to be using CCDs. If you want to visually discover a comet, if you live in the northern hemisphere, I think you're pretty much out of luck. I think there still might be possibilities in the southern hemisphere. The one comprehensive survey that was operating in the southern hemisphere was the Sighting Spring survey that was based out of the Sighting Spring Observatory in New South Wales. The funding for that program went out about a year and a half ago, so there's no comprehensive survey in the southern hemisphere at this time. I mean, Terry Lovejoy is still finding comets, but he's only one person. And can't.
Do you think that amateur astronomers should start concentrating in the areas where the professional surveys aren't looking? We did actually ask Leonid Enelin that question on our very first show, and that's where he seems to be finding them, is by ignoring the areas, mainly where the big surveys go, and then looking in those little spaces there. Is that the way forward, do you think?
I think pretty much it has to be. And that's what Gennady Borisov in Ukraine has been doing, looking for comets at rather small elongations. I mean, there was the recent comet that was discovered in the Swan images was visible in the southern sky, but again, we don't have a southern survey operating right now, at least no comprehensive survey. And also, that comet is it was a dynamically evolved object, rather short period. I think the latest orbit calculations indicates an orbital period just over 2 centuries. And those comets sometimes tend to remain faint and then brighten as they approach perihelion. So that may have also contributed to the fact it wasn't found earlier than it was. But even that one is at a very small elongation right now. So obviously, I think if someone wants to find a comet doesn't have a name like Pan-STARRS on it, you're going to need to look at pretty small elongations. And if you want your best chance to move somewhere to the southern hemisphere.
Oh, I could think of quite a few people that will probably jump at that chance. But
we must stress, mustn't we, Nick, that if anybody is listening to the show and new to sort of like looking for comets, and really would like to have their name on a comet, they must be very careful when looking towards the sun, mustn't they? Because when we're talking about small elongations, if you get it wrong, you could be in trouble, couldn't we?
Absolutely, yes. We definitely never point your telescope towards the sun.
No.
And if you must,
just in case,
project the image.
Yeah, just in case people start sweeping near the horizon, you know.
Yeah. But small elongations, of course, now you've got the LASCO chronographs aboard SOHO. You know, they're finding comets within, C3 finds comets out to about 8 degrees from the sun. So you don't have to worry about anything closer to the sun than 8 degrees, because LASCO is going to find it. Like this most recent non-group SOHO comet that's disintegrated, although there's still a tail remnant left, and which I very frustratingly haven't had much of a chance to try for yet. We've had very lousy weather here in New Mexico. We've been in a storm track for the last 2 to 3 weeks. We had gorgeously clear skies right when the moon was full, and now we're back over.
That's it. Always the way.
Well, I have a.
I actually caught the. Sorry, I was going to say I actually caught the one early last week, and it's a very, very small blur in my telescope. I'm afraid about 11th magnitude then, and then the moon got in the way. So I think I've lost that one now. It's going to go down to about 13th magnitude very soon, I'm sure, and lower. So.
I was going to say I know what the feeling's like, Alan, because I have a residence in upstate New York, and during this time of the year I'm normally socked in with nothing but snow.
Yeah. It was the original forecast for this week. Recall that was going to be nice and clear, but yet the system moved in from the tropics a couple of nights ago. So last night was the first night with any darkness. Last night was overcast, of course.
Someone must have been buying some piece of new kit in your area. So I think that's the normal jinx, isn't it? Someone buys a piece of kit, everybody gets socked out.
That's right. That's it.
Yeah.
Have you any interesting projects on the go at the moment, Alan?
Any? Could you repeat that, please?
Yeah. Have you got any interesting projects on the go?
The one thing I've got going on right now is a book I've been working on for over a year. It's kind of morphed somewhat from my original intent. I started the book in late 2013 as a discussion of my comet observing experiences. I've been observing comets since early 1970 when I was kind of young. I'd like to think I'm still kind of young, but that's a matter of definition, I guess. And I was going through kind of some emotionally difficult times at that time, and I started the writing as therapy. And then my mother died a month later, which didn't help. But as I kept writing, the project kind of took on a life of its own. I've seen a large number of comets visually in my life. It's well over 500 at this point. And it's not a discussion of every single one because, let's face it, the majority of comets that I look at are very faint, very unremarkable, to the average person extremely underwhelming. So I picked out what I called my top 10%, and that's not only the 10% brightest, but those that are important scientifically, a Shoemaker leaving 9, for example, those that have a strong personal significance to me for some reason or other. And so I was writing about these with my life story kind of thrown in and around it. And as the project continued to evolve, it has morphed somewhat into almost what I would consider an autobiography. And I finished the initial manuscript at the end of the year last year. In fact, my target date, I wanted to finish by the end of 2014, and sure enough, I finished the manuscript at a little after 2:30 in the afternoon on New Year's Eve. And since that time, and around my day job, I've been doing some revisions, some updates. The process of getting permissions from people who take images and photographs, that's always kind of an interesting process, but I've got that mostly complete right now. And I'm going to actually start kind of doing an autobiographical update and revision. Actually, I'm starting that this week. And my goal is to have this available and publishable as an ebook and have it come out on the 20th anniversary of the Hale-Bopp discovery, which is this coming July.
Do you have a provisional title in mind?
A what up?
Do you have a provisional title so we can we can put the word out into the community and so that they know what to look for?
Yeah, well, my working title has been Alan's Best Comets. That's just been my working title. I am leaning towards The Comet Man as my title. I haven't made the final decision on that yet. I'm leaning towards that title because when I've been going through all the old pictures and stuff that I've taken, of course, I've gone through a whole bunch of stuff, and I came across a story that my older son wrote when he was in 3rd grade, I think. Submitted to a local writing fair, and he's on the front cover page, he put his name, and then in parentheses wrote, "Boy of the Comet Man," because this was right when Hale-Bopp was starting to get bright. And I thought that was kind of cute, so I was thinking of taking that phrase, "the Comet Man," exactly as it appears on the front cover of this story, and using that as my title. And I asked him about that. He's okay with it. So I'm leaning in that direction, but I haven't made any decisions yet.
Well, this definitely sounds fascinating, and I'm certainly going to pick up a copy when it comes out. So please do let me and Neil know when it's available, so we can actually go and get it and have a good
Absolutely.
read.
Yeah. Well, I said the target date is July 23rd.
July 23rd.
Because that's the 20th of the Hale-Bopp discovery, and so far it looks like I'm able to hold to that. It's a process. It's a long time, but I got kind of an early jump on it. I've gotten over 90% of the permissions for the pictures and images and stuff like that. And I know it will take a while to track down that last 10%. It always does. But I'm well on the way. So, Sam, just this week, I'm going to start the entire autobiographical revision and update, and I hope to have that done by about the end of the month. And then it's time to give it to the proofreaders. And that's always kind of a cringing experiment, but that's part of the process that has to be done.
I think one question that a lot of people would have on their minds is, what would you say was your top 3 comets?
if I were to say top three, does not necessarily mean the brightest, although they are, that kind of encompasses that. But the three most notable, most important, I guess, well, obviously Hale-Bopp would have to be one of them. I would say Comet West in 1976, which was the year I graduated from high school. I mean, that's actually been the best comet I've seen. I remember at the International Conference on Comet Hale-Bopp in the Canary Islands that was held in 1998, I met Richard West. And we got into a friendly little argument on who had the better comet. Both of us taking the position that the other had the better comet. I was arguing that his comet was better, and he was arguing that my comet was better. But I mean, it was all playful and good fun. I mean, it was all that. But I definitely consider Comet West to be the best one I've seen. The other one that it wasn't among the very brightest, although it was definitely an easy naked eye object, but certainly had a large influence on my life, especially in terms of all the events that went on, was Halley.
Mm-hmm.
I mean, yeah, I mean, Halley was, as you'll read the book when it comes out, my life underwent a huge upheaval in events when Halley was around.
Yes, I remember Halley's comet with happiness. I think I seriously got interested in comets at that point. I can just about remember Comet West back in '76. I think Patrick Moore over here did a thing on the Sky at Night about it, but certainly everything was all about Comet Halley, and of course Giotto and the Vega spacecraft that were all going to go there for the first time. And I have to admit that with the Rosetta going on right now, we've definitely come on leaps and bounds. It's just amazing what we're finding out. What are your thoughts on Rosetta and actually going to a comet and staying there for a while?
Oh, I think the whole thing is rather fascinating. I think ESA did a magnificent job with the entire Rosetta mission and being able to pull this thing off. And I'm following the results and looking at the images just like everyone else is. I have a kind of a personal significance for that comet. That was one of the first comets that I learned about when I actually really started studying comets, because it had just been discovered. And I had the pleasure of meeting Klim Churyumov at a conference a number of years ago. And I've seen that comet on several returns, and I'm looking forward to seeing it on the its return later this year. The geometry is not that good. Yes, but I observed the same in 2002 under very similar geometry. So I expect to be able to observe it. It's just not going to be very overwhelming. In fact, when I tell people about it, I said, you're not going to be impressed when you look at it with a telescope.
Yeah, I seem to remember they said that about Halley on its last apparition. It's not a really good one, and the next one's even worse. But it's still something to say that you're looking at an object that's taken several trips around the solar system, just for you to see it. But I think it's really good that we've taken comets away from the area of terror and brought them into the scientific world and made them see them as almost as a time capsule of the early solar system, something which of course is very difficult for us to look at apart from in the asteroid belt. So as I say, it's I think we've done quite well with this now, and I'm really pleased with the results. Well, Alan, is there anything else you'd like to talk about?
I don't know if I really have anything particular. In 2061, the geometry is not very great, but we have the potential to have a brief show that'll be pretty decent, although it'll be the small elongation. So, 61.
Yeah.
If we were seeing, it's going to be 103 then. So, I don't know. ex-girlfriend, whom I'm trying to convince to be an ex, visited in 1986, and I promised her that if she would hang around with me until 2061, I would show it to her. So,
Yes, I'm 50 already, and so I hopefully I too will still be here for it. Wouldn't it be great if we could all get together just to look up for that one night and say we made it back to see you again?
If you could make it
Alan, could I just...
to the following 34, the return in 2134 is excellent for those who are going to hang around that long. I consider.
No, that won't be me. No. Alan, I just want to ask you. Oh, sorry. Carry on.
But no, go ahead.
Oh, yeah, I just want to ask your opinion. One question has always bugged me, and if I ever got a chance to talk to you, I would love to ask you this. When you were waiting for your comet to come along in 97, of course, the year prior to that, for the Northern Hemisphere, we had a great comet, didn't we? Comet Hyakutake. And I just wondered how you felt as that was going through the sky, and you knew that your one was coming. It was expected to be good, but this one all of a sudden sprouted a 100-degree long tail and was 0 magnitude. Did you think that, you sort of like you might get outdone by an upstart sort of thing?
No. I thoroughly enjoyed Comet Hyakutake. I mean, it was a magnificent object from here. I realized that Hale-Bopp would have a pretty hard act to follow, but it had been 20 years since we'd had a great comet in the sky at that point, and it was nice to have this one. I mean, my ex-wife had been with me for some years, and I would take her and show her some of these comets, and she'd go, "Wow!" And even Halley, of course, which was not, even though it was a fairly bright naked eye object, certainly was not a great comet when it was around. So Hyakutake was the first great comet I was able to show her after either, I guess we'd been married for about 11 years, but 85 years before that, so 16 years. I finally was able to show her what a great comet looked like, and she was actually quite impressed with Hyakutake, and I just thought it was great that we had this one bright comet, and then we have another bright one coming the next year. They were very different in terms of their appearances. It was a very apples versus oranges comparison between the two. I know there are a number of people out there that thought Hyakutake was the better comet of the two, and that's fine with me. I thought that Hale-Bopp was slightly better, but my opinion is not entirely objective either. And I mean, I've got a vested interest in Hale-Bopp in this performance, but I just thought both comets coming quickly like they did, I thought was just wonderful for the whole field. And my one regret is that I never got a chance to meet Yuji Hyakutake. He passed away not too long thereafter, just a few years. I never had a chance to meet him, and I'm sorry that never had a chance to happen.
Well, I want to thank you, Alan, for coming on and talking to us today. It's been a great honour, I must admit, because Hale-Bopp was one of my favourite comets. My favourite image, of course, is the one they show over Stonehenge. So.
Mine too. Yeah.
But again, that's personal bias because I'm British, I suppose. But yeah, it's been really great talking to you, and I really thank you for giving us some of your time today. And I'll be looking out for your book when it comes out in July. And I would like to know if once it's out, if we could have a chat with you again at that point. Would that be okay?
Yeah, probably. Certainly because at that time, of course, I will want to publicize the book as it comes out. I did not write the book to make money. I mean, obviously, I will accept whatever proceeds come in, but I wrote the book because I felt like I had a story to tell. And I just needed to tell the story. I mean, there's lots of comet books out there. If you want to learn about the science of comets, there are plenty of books out there. But this was a personal story. I'm not just an astronomer. I'm not some guy who found a comet, but I'm a thinking, living, breathing human being who has suffered the downfalls of life. I've experienced the upper parts of life, just like almost everybody else does. And I just wanted to tell my story, and that's what the book is about.
And
with a bunch of comments.
Yeah, I'm looking forward to that myself. Because it sounds a fascinating read, and I'm certainly going to get that. Neil, over to you.
Yeah, thank you very much, Alan. It's been an absolute pleasure talking to you. Looking forward to the book. I can't wait. I want a copy of it now. I can't wait until July. I can't wait until July the 23rd. I need it now. Anyway, it's been an absolute pleasure talking to you. Nick, what else can we cover up for this part of the show?
I just think we should just say thank you very much, Alan, and it's going to be really great to talk to you again later on in the year. And
yeah,
thank you. As I say, a lot of people will probably find this whole different side of the Hale-Bopp story great to know, because we're all human beings and we all come to the sky for different reasons. But yes, it has been a great honour, and thank you very much for talking to us today. Thank you very much, Alan Hale.
Thank you. Thank you.
And welcome back to the show. We now have our second guest of the evening with us. Would you like to please introduce yourself?
I'm David Eicher, the editor-in-chief of Astronomy Magazine over here in the colonies.
Yep, welcome aboard, David, and nice to have you with us. Now, as I
say,
thanks
for having me.
Yeah, it's always good fun. And of course, you're a fellow comet buff like myself and Neil and Alan Hale, who we were speaking to a bit earlier today.
Yes.
So, would you like us to give the US perspective on comet hunting and your perspective as the editor-in-chief of Astronomy Magazine?
Sure. Well, it's something that personally, from my point of view, it's really an amazing thing for me, because I fell into astronomy as an observing experience just when Comet Vest was getting really bright in the spring of 1976. And so that was really the first astronomical object for me personally that I went out and got really excited about. And then I got into being more of a deep sky observer, but of course got into with editing Astronomy Magazine, which is the largest publication about astronomy for astronomy enthusiasts. You need to be pretty good at everything. And so I kept observing comets a lot and became friends with a lot of cometary observers, David Levy and Jim Scotty and Alan Hale and others. So for me, comets are a very important area of what I'm interested in, and what American astronomy enthusiasts are interested in as well. They love things that you can see in the sky that change, and of course comets are at the head of the list with solar system stuff as far as that goes. Of course, it's a bit of a challenge here as time goes on, as it is everywhere with finding a good dark sky with increasing light pollution. But Americans love to observe comets, and I expect that they will for many, many years to come.
Now, given the fact that there's so many automated surveys out there, we've got the Sloan, we've got Pan-STARRS, we had Linear. Where does the amateur astronomer, let's just keep it to the amateur astronomer, fit in today as a comet hunter?
Well, I think you can still go out there and do it, and of course, hunting at the right times is critical. But and it hasn't gotten any easier, obviously, with more surveys underway and more to come in the future, certainly. But I think being out there in the evening at the right time and in the morning sky. And if you believe David Levy and his cometary techniques, the morning sky is the best time to find a comet that sneaks up on you and that maybe surveys are not going to catch as quickly as you do, because you're out there every night looking when it's clear. So I think, I'd like to think that amateur astronomers can still play an important part in discovering comets in the future.
In fact, just as you're saying that, I've just got a message. Our second guest is ready to be brought into the call. So I'm just going to just pop over and do that. So
sure.
Just 1 second. Okay. Right. Okay. So, as I say, I do apologise for all the hums and ha's and bits here, because sometimes... Right, okay. I'm going to add our next member for the call. Okay. And I'm hoping that he's bringing him in right now. Please. This is the fun of Skype, folks. I'm bringing in another. Right. Okay, let's try doing this one. Yeah. Okay, add people to the call. I think this is the fun of it also from my point of view. Neil and I are both amateur astronomers, and we are not professional commentators, so to speak. We're not.
No.
Well, you're doing a good job.
We're certainly not in the
you're
Patrick
playing a
Moore
good
class.
You're playing a good job of being a commentator on internet radio. You do a nice job with the program.
Thank you. Okay, now I'm going to bring our
Thank
next
you.
guest in, and he's now being dialed in. Fingers crossed. Hello. Okay, great. Our second guest has now arrived. Great to have you with us. Would you like to please introduce yourself?
Say again, I didn't understand that.
Oh, hi. Would you like to say hello and introduce yourself? Because we've got David here from Astronomy Magazine, and Neil and myself.
Okay, hello, this is Jim Scotty, U of A.
Welcome aboard, Jim. Thank you for joining us tonight. Now, we've been just talking with David about amateur astronomers and comet hunting and where they fit in regards to the all the surveys going on. And do you feel that there's space for the amateur astronomer in comet hunting still today?
Oh yeah, I think so. They won't be finding any comets near opposition that haven't been found by all the different big surveys, but there's still a big area near the sun where comets are, diving into the sun or coming out of the sun that don't get very well surveyed. So I think they definitely have some opportunities there for comet discovery.
Now, a lot of people are now looking in the spaces, seem to be concentrating on the spaces, and the surveys don't look at. And what was it Alan said earlier, Neil? The short elongation. Is that right?
Yeah.
That's right, yes.
Yeah, that's right.
That's what he was talking about, wasn't he?
Now, for a lot of people who don't know, you were actually involved with Shoemaker-Levy 9 and when it struck Jupiter back in the day.
Yeah, that was a lot of fun back then.
And I think we've only ever had one actual recorded Jupiter strike that made the news since then, which was the Weasley spot. How do you feel how amateur astronomers are fitting in? And I'm going to throw this open to David as well afterwards as well.
Yeah, for finding objects like Shoemaker-Levy 9, obviously I don't think the amateurs are going to be able to do very much of that, but if they can monitor Jupiter, they can certainly do a more thorough job than the professionals can. There are a lot more amateurs out there potentially to observe them, and they can watch the planet for more or less full time if they wanted to. Whereas there aren't too many professionals who'd be able to do anything near that. We basically just sample things like Jupiter these days, unless you wanted to fund a specific program that sat there and watched Jupiter full time, which would probably be pretty interesting to see.
David, what's your take on this?
Well, and I agree.
Sorry, go on, David.
I'm sorry, I was just going to say I agree, and hi, how are you, Jim? It's nice to talk to you. Jim and I think, have known each other since we were teenagers, more or less. But I agree.
Or at least we looked like teenagers.
Right. I think it's, amateurs have the capability of providing person power. And, of course, the numbers of professional astronomers are not what they could be in some ways now with funding the way it is. Professionals are swamped in terms of focusing on very specific projects in some ways. Amateurs can provide a lot of person hours on an eyepiece, and also with CCD cameras and can really concentrate on various things that maybe some professional astronomers can't put their time to. And of course, if we go back 20 or 25 years, practically to the time that we were teenagers, Jim, it used to be that professionals would say, well, this is great, the professional amateur cooperation, this is fantastic. We love the help and support of amateur astronomers. And there was kind of a little wink there, and you couldn't really, in a lot of cases, trust data from amateur astronomers. Well, that's not the case anymore. And I think Jim can say more than I can about this, but now we've got the instrumentation and the calibration and the precision of the equipment that's in the hands of some amateurs. That's really usable data now in the eyes of professional astronomers in many ways. So that game has really changed over the last generation as well.
Yes, I can speak to asteroid research in particular in that regard. The amateurs are contributing greatly to follow-up of near-Earth asteroids newly discovered that are relatively bright. We almost feel like we are wasting our time when we chase a bright object with our relatively large telescopes that can go a lot deeper. We concentrate on the fainter stuff that they can't get to, but they certainly save us a lot of time, I should say, having to follow up the bright stuff that is relatively easy to see. Same thing with comets, I think. They can monitor comets much more extensively and observe brightness changes, structural changes in comets, maybe new tails or whatever else might be going on with all the comets. There's no way, even if I wanted to, that I could observe all the bright comets that are available at any given time. And by bright, I mean brighter than like 20th magnitude. That's pretty faint for most people, but...
Well, I know, because I know a lot of us are using the robotic telescopes around the world, and
that's another advantage.
And we're working down to magnitude 13, 14, 15, and deeper. And I think even 20 years ago, for an amateur astronomer to be able to do that, it was like, yeah, right, I'll believe it when I see it, because it just...
that was unheard of 20 years ago. It really was.
Yeah.
In fact, it's... I was imaging Lovejoy about 3 nights back, I think, and looking at the tail structure you can see in modern imaging. I remember looking at pictures that were being put on TV. You saw a heavy white tail on a comet. That was considered to be a brilliant image. Now we're actually we're putting pictures up of that's showing great detail. And let's say Lovejoy right now, you look at the tail and you can see distinct strands to the tail. As I say, I remember everybody used to say, well, we look at a comet today, it's a solid tail. Now, back in the 21st century, amateur astronomers can make out fine detail. As I say, it's been great. It's great for us, and I know that David, with the magazine, you actually have a gallery for the readers to send their pictures. And I remember back early. I'm going back to being able to read very early astronomy magazines from the 60s and 70s, and looking at the difference between the images there and now, it is completely different. Where do you guys see amateur comet hunting going?
Well, it's really quite remarkable. You're right, as far as the images go. I mean, even just in the last 2 to 3 to 4 years, I mean, there are images of things that are a few years old, and they're just not as good as what you can do now. And I mean, as one benchmark with comets, you look at what Damien Peach has done with Lovejoy, and even ISON and others recently. It's just incredible detail now, the technique. And so what's remarkable about what you can do if you really want to get into this and do great imaging is that you get lots and lots of images sent to you, and all of a sudden there are names of people who are popping up who you never heard of before. These are their first submissions, and these are incredibly detailed, remarkably good images. And back in the day, you would have thought there's no way this new person is is producing this stuff. Well, now you can, if you apply a bit of persistence and intelligence and care in the technique and, quite frankly, enough money to have the system to do it. It's really incredible what amateurs can do now. You're right, and it really makes images of even 5 and 10 years ago really look somewhat crude in terms of technique, even in the early digital age of imaging compared to what can be done now. So, discovery is one thing, and going up against the automated surveys is one thing. And we talked about finding comets potentially that are sneaking in from behind the sun. But certainly imaging, amateurs can do a lot of imaging that professionals wouldn't do in terms of the kind of imaging they're doing, the plate scale, the wide fields, etc., that are just getting better and better and better with every comet that comes by. And so it really is incredible what amateurs are doing, and I think will continue to do in terms of astro imaging of comets.
I think the equipment that amateurs have is so much better and a lot more affordable for them to obtain. Plus, there's software that's more or less canned that they can learn how to use very easily and quickly to produce remarkable results without having to, become a super expert like our dear departed friend Don Parker from years past.
What a terrible, terrible loss we've had here in the amateur community, the greatest planetary imager of his generation.
And an innovator in many ways.
I have to admit that we all know the most well-known package for imaging. Yeah, we can say it is MaxMDL. Everybody's use that at some point, and the learning curve on that is getting quicker and quicker every day. They've gone through so many versions of it to date. I think they're in version 6 or 7 now. But
yes,
it seems to be that every time they do a new major version, the learning curve on it really, really speeds up. I got it back as version 4. It took me 3 days of head banging at one point, literally on the desk, because it was driving me nuts. To get it, and of course I had friends sending me FITS files to play with so that I could actually use it. And in the end, one of my friends said, "What's the problem?" I said, "Trying to do this, trying to stretch it and do this, that, and the other, and integrate it." And he says, "Give me 5 minutes, I'll give you a call." It took him 5 minutes to take me through the whole process, and I've been trying to learn this package for 3 days, but it is great. And what's the best way to put this? Where do you see the whole situation going? Do you think there's going to be a total situation where in future it's going to be pro-am collaborations on imaging and data retrieval?
I was waiting for Dave to just pipe in there. But,
I'm sorry, I was waiting for you. I think so. I think there'll be more OEM collaborations, and I think the kind of thing you've seen it somewhat with Tony Hallis, you've seen it with Rob Gendler, you've seen already some hints of this, of some literal collaborations with imaging happening between professionals and amateurs. But I think Jim knows better than I as far as solar system objects where this really might be going.
Yeah, we definitely see a lot of amateurs and groups of amateurs. Nick Howes, for example, with his group, and there's other groups that are in education that have been using things like the Falks telescope to image comets and asteroids and do things that we probably don't have time to do or hadn't thought of and stuff like that.
Do you see it as an ongoing educational advantage to have telescopes like the Falks telescope available to schools?
Definitely. My wife is a high school science teacher, and she's definitely expressed some interest in being able to use equipment like that and getting her students involved in a way that might tweak their interests. I can think back to when I was in high school and just just dreaming of the possibility of being a professional astronomer someday, and having the availability of something like that would probably have sped up that process considerably.
What's your thoughts, David?
I agree, absolutely. I think it's crucially important, and it becomes more important every year as more and more kids who are in schools in cities. Remember that a lot of people are, as they grow up now, are getting bits and pieces from television, from a half an hour every week on Nat Geo or the Science Channel or something, and even less than that in terms of their exposure to what the universe really is and what's out there, and they never see a good sky. Remote telescopes getting imagery of real astronomical objects into classrooms will be dramatically important in the future and only become more important. And I hope that educational systems will understand that and will recognize that and apply some money to supporting it.
One of the things I'm looking forward to when I move back to the States, which is going to be next year, which is the end of this year, is I'm hoping that David Levy is going to hold one of his star camps back in Adirondacks again fairly soon. That's something I've really got my heart set on going to do. I have to admit, I've heard about it over a period of years. Put in for time off to go to put, so I can actually go to it. I've never got the time off, unfortunately, but I think over the next few years, if David does his star camp again, that is something I want to do. Now, would you recommend events like that for prospective comet hunters or observers?
Absolutely. I mean, if David is feeling good, if his health is where it should be, I think he will do that again. Jim, you probably know better than I. You're across town from him. But this is a hugely important to hear from people like Jim, from people like David, from people like Carl, who works there as well, from people like Rick Hill, people who Richard, who have discovered comets. And of course, David's gotten a huge amount of publicity in the past for the writing he's done, for his association with Gene and Carolyn, for SL9. There's nothing, I think, that's more inspiring to me. I've never discovered a comet. I've had the good fortune to know a lot of people who have. There's something that's more inspiring hearing about that experience and what it's like and what they've been through, to me, than anything else associated with cometary science. So I certainly hope that will happen again with David. And I hope that we'll have the chance for many young astronomy enthusiasts to talk to people like David and to Jim and others and hear how a discovery has inspired them.
Neil, would you like to ask a few questions yourself as well?
Yeah, I just want to know what Jim and David's favourite comets were.
I didn't quite hear the question. Say again.
Oh, sorry. Yeah, I just wondered what your favourite comets were as you, since you began your career, or when you were younger, before you even got into your career.
Famous or favorite comets? Oh boy, that's a tough question to answer because I have too many favorites. The best comet I enjoyed observing visually with my own eyeballs had to be Hale Bopp. Because it was bright enough to just wander out in the morning with sleepy eyes even and look out, and there it was every morning for a month or so. And it was an old friend by the time it suddenly wasn't there anymore. It was like, oh man, he's gone. But that was really fun. Comet Halley got me interested just because I knew about it since I was as young as I could be to learn about it. It's off in the future when Comet Halley is going to be so bright and spectacular to see. So there was the anticipation in that regard. When I was just getting into astronomy back in the early 70s, Comet Kohoutek made its splash. And I got my first telescope at about the same time that Comet Kohoutek became its brightest. but not because of Comet Kohoutek. I was actually getting into astronomy independently, but there was Comet Kohoutek. I never saw Comet Kohoutek with my own eyeballs. I lived in New York City at the time and didn't see it. But I heard all about it and was really excited. And if I'd known I was going to be so into comets later, I probably would have tried harder, but that was exciting. But probably the most important comet to me has to be Comet Shoemaker-Levy 9. Being part of the discovery and confirmation of that object, and then observing it for the next 15 months as it orbited around Jupiter, and watching how the pieces changed in position and brightness and things like that, and then being a part of the team that watched these things barrel into Jupiter and do what they did there. That was career changing in a lot of ways for me.
Awesome. David?
And I'd have to agree with Jim that clearly, there's this phrase "great comet" that gets bandied about a lot, of course, and there's no real rigorous definition of what a great comet is. But it's like, they say, Alan Stern says about planets, you know one when you see one. And clearly Hale Bopp was so stunning. It was something you could take your Aunt, Matilda out with no dark adaptation, look up, and she'd say, wow, holy cow, And so that was really incredible. I would have to say Yakataki as well for its incredible tail length. And Vest, because that was really bright and just when I was getting into astronomy. And then one that wasn't really a great comet, but it was really cool, I thought, in 1983 was Iras-Araki-Alcock, because it was a physically small comet, but it was so close to Earth that you could watch it move over the course of part of an evening against the background stars. That was really, really cool, because it was just a big, fuzzy cotton ball, but just watching it move so fast was really incredible, because, as you know, so much in the sky is so distant that you never see it move at all.
Yeah, I can agree with that. Can I amend my list and just add those guys as well, and other comets? Sheesh. I've observed hundreds of comets professionally, and all of them are interesting in some way or another. They might show a tail where others don't, or maybe become active at random times, or just there's so many interesting ones out there. It really is hard if you start talking about interesting comets not to include probably 100 other comets out there. They're all different, but they're all similar in ways. They have their own personality, and it's really fun to watch them and see what they'll do.
If you were to, this is a question for you both, if you were to describe a good starter setup for somebody coming into comet observation, what would you suggest equipment-wise?
Can you include a 4-meter telescope? I guess not. Well,
well, why not?
I guess I'll let Dave answer this one, because he's probably more into the kinds of setups that the average person might be able to afford and put into operation.
And I'm sort of echoing, as I recall, my good friend, our mutual good friend David Levy, and what he's said in the past. I think he's sort of encouraged for a beginner, someone to both observe comets and also sweep for them. Now, he's not going to, be sending someone to a 16-inch short focal length reflector, but I think either a 6 or maybe even an 8-inch short focal length telescope, a wide field, but a 6 or 8 inch mirror that would give and provide enough light gathering power, both for sort of sweeping with a relatively low field in the evening and the morning skies, and also for being able to crank up and just observe and enjoy looking at comets. That would give someone enough light gathering power, also a relatively wide field, be relatively inexpensive to get started and get into the activity, the hobby, and I think that would be sort of a good overall package to start with, and that's really echoing the advice of our buddy David.
Yeah, I would add for big bright comets, if in the next couple of years, hopefully some big bright comet that's going to appear, say, next year or something like that.
Yeah,
I
that's what
remember
we
answering
need.
this
Yeah.
question I remember answering this question for Comet Halley way back in the day, and I used to tell people, get a good pair of binoculars. It's going to be bright enough that you can go out, you'll be able to find it with your binoculars because it's going to be relatively easy to find. And you're not going to put the binoculars in the closet like a telescope, because if you had a medium-sized telescope but no experience as an astronomer observing, you'd take the telescope out, you wouldn't be able to find the comet, you'd be frustrated, you put it in the closet and forget about it. Whereas the binoculars, you take them out, you find the comet, wow, and then you can take the binoculars to the football game or the baseball game and use them there as well, or go bird watching with them very easily. And they're more useful then for the average person on the street, especially when some bright comet comes around.
Yes, I have to admit, one of the things I've always recommended is get a decent pair of binoculars, start with them and work up to a telescope. Okay, I slightly cheated when I was younger. I went and bought a 10-inch Starfinder Newtonian, non-driven. So you can imagine I'm busy. I've got one eye to the eyepiece and I'm cranking the drives manually just to keep the moon in place. But as I say, some people. Well, I made a slight mistake there, but I think that was my third telescope at that point. I started off with the El Cheapo refractor from Woolies. It was 1969. It was the lunar landing. Everybody was looking at the moon, and then I got a 4.5-inch reflector. Again, not motorized, but it was fun. It kept me interested. I could lug it around the garden if I had to, and I guess I got aperturitis at the end by that point, and so I got something slightly bigger. And at the moment, right now, I suppose some people I totally cheat. I've gone to GoTo. I love GoTo because you can just feed in the coordinates, go straight onto the object, and start observing, and did not worry at all about tracking. But binoculars is definitely the best thing to start off with. Anyway, again, if you get bored with astronomy, bird watching, the game, it's all there. Neil, you're next up with some questions, I hope.
You run out of ideas, Nick. The Rosetta mission. I'd like to know Jim and David's opinion on the Rosetta findings so far that we've had, and hopes for the future too.
Well, that's been a lot of fun to watch. To watch the spacecraft slowly approach Rosetta, seeing new features every week or so, just like watching Dawn go into Ceres, and it reminds me of when I was a kid, and the first view of a new place, like when Neil Armstrong stepped on the moon. That was the first time we got to see a new planet or a new world that humans were on, and then later Viking landing on Mars, seeing the first pictures there. This is the same thing. You go into orbit around this little guy, and you get to see this place that we've never seen before, and what it really is made of, and what its structure looks like. And everyone who thinks they were a comet expert is suddenly saying, "Wow, I never thought of that before. Oh, look at that feature. Oh, ooh, wow." That's really fun. And then the lander doing its little bouncy maneuver there. I sure hope it turns on someday and tells us some more about what it found. But that's been fun to watch.
Now, I know that both ESA and NASA have got asteroid retrieval mission plans in advanced stages. Do you think we should have some more missions to comets with more Rosetta-style probes?
Yes.
I would definitely agree, yes.
I know one person said to me when Rosetta was actually the rendezvous was happening, this is going to be the mission that rewrites all the books, because we've got all this wonderful literature about comets, and we're actually going to get a space probe there, and everybody's going to be on hold literally before they write another book, because they want to see what Rosetta finds. Do you feel that's the case, and with successive missions that will still be the case?
Well, I think every comet is going to be a little bit different. It's had a different history. It's been maybe in the inner solar system longer or shorter, depending on where it came from, and maybe it formed in the Kuiper Belt as opposed to maybe being a long period comet that formed out actually closer to the sun, and then have been spending most of its time much further away from the sun. So they'll all look a little different. Maybe some of them might have been impacted by things, others probably never have, or very rarely have. One might have more ice on the surface than the other, or different kinds of ice. Yeah, every one is going to be different, just like they've shown us in the past when we try to make predictions about how bright this or that comet is going to be when it's at its brightest. And everybody looks pretty silly at the end of the day when the comet does whatever it was going to do anyway, regardless of what the rest of us were telling it that it should be doing. So I think every new picture of a comet nucleus will tell us some new things about how comets behave and the range of things that they will do for us or do in front of our telescopes and spacecraft. Can't wait to see the next one.
Absolutely agree. And of course, we know what we know about cometary nuclei as objects from only a handful of missions. The Rosetta mission is extremely exciting, as Jim said, because we're seeing this a cometary nucleus at unprecedented resolution and with detail that we've never been anywhere close to. But we only have a very small sample of what's happening with comets as physical objects to draw on, and so it will rewrite our knowledge with each mission, and we're going to have to remember that we're looking at a small number of individual objects here. We know the only cometary sample recovered and returned thus far from the Stardust mission, we found glycine in the simplest of all the amino acids. So one of the so-called building blocks of life we found in the only comet that's been sampled so far. We have a magical year going on, of course, with the Rosetta mission, and then later with New Horizons flying by Pluto in July, and that's going to be a very slow data download over 16 months then. So all the information is going to go on and on and on and on for months, even though it's a very quick flyby. Just because of the way these are inexpensive missions, but we are going to learn a lot about these small bodies in the solar system. And it used to be, of course, 10 or 15 or 20 years ago that comets and asteroids were thought of as two completely different things. Now we know that they're really related cousins, and that some asteroids are defunct comets, and vice versa. They're all sorts of crazy orbits. So I think this year, because of Rosetta and because of New Horizons, we're going to start to get a little bit more complex picture of these small icy bodies, but we do need more missions to really understand very much at all about their history, about their formation, about their evolution in the solar system. It's a gigantic puzzle.
I know this is.
What we really need is some new rocket engines.
Oh, wouldn't it be nice if we had
big rocket engine? Yeah, big rocket engines to get to different kinds of comets as well. We have to get to comets that are easy to get to. Churyumov-Gerasimenko was chosen partly because we could use gravity assists and then ion engines to slowly rendezvous with the thing and go into orbit around it. But imagine trying to do the same thing with Comet Halley or any other really elongated orbit comet. It would take a huge amount of energy to change the orbit of the spacecraft to rendezvous and go into orbit around something like that. So, yeah, we need bigger, better rocket engines. Where's the Starship Enterprise when you need it?
I was just about to say that. Wouldn't it be nice to have an impulse drive that we could just borrow temporarily, send out a space probe to Halley's Comet? And I suppose really for the modern generation, the whole thing for us has really kicked off with Giotto, because it was the very first close-up image we ever saw of a comet nucleus. And then a few seconds later, of course, we lost the camera because of an impact. But you know what? That must have been a really important day for both of you guys.
Yeah, watching what happened there with Deep Impact was pretty exciting. one possibility is that the impactor might have just gone straight through the comet and come out the other side without hardly doing anything. I didn't expect that to be the case, but you never know. Comets might be so light and fluffy that it would hardly notice the comet as it went by. So there were a lot of questions about what would happen there and what we would see when it actually did hit, and it was pretty exciting to watch how that went about. I was trying to watch it with our 1.8 meter telescope on Kitt Peak when that impact happened, and unfortunately it was setting at the time that of the impact, so I didn't get to do much with it during the actual event.
Yes, I remember the experiment they did with the lunar probe to see if we could observe the actual impact here from the Earth. And in a lot of places, the weather just was not cooperating. But if you had to have a mission to a comet, now, would you want a sample return, or would you want a Rosetta-style mission? And which comets would you both pick to be visited for this the preferred type of mission?
That'd be tough to choose. There's 10 Comet Scotties that I wouldn't mind having them all to go to, but I suppose that wouldn't work too well. Sample return versus being there. To sample return, you almost have to be there anyway, so you can almost do two things at once. I'm tempted to cheat there and say, oh yeah, we can do both of those at the same time with one mission, because while you're going into orbit around the thing to put your sample return equipment on the comet, you have to linger there long enough that you're going to study that comet almost as well as a Rosetta mission would. So yeah, I'm going to cheat and say that's the answer there. Which comet? Man, there are too many to choose from. All of them are interesting in different reasons. So I'll go back to my original answer. Comet Scotty. Okay. Take your pick, any of the 10.
Now, would you want to do this whilst the comet is far out in the solar system, or when it's closer into Earth?
I think watching the comet come into perihelion and watching it become active to see how its surface changes as its distance to the sun changes will be a very important thing to watch. Rosetta is doing that now, and seeing where the active regions are on the comet, how they actually behave. We have ideas about how those work, but to actually see them and study these active areas, seeing how they change during an orbit around the sun, how they produce the material that we see is in the coma and the tails. I think that's a very important thing to study. Plus, learning the chemistry of what the comet is made of, watching that to spew out its material from different parts of the comet would be, I think, an important thing to watch.
I would agree, and it would be nice ultimately to sample a comet that lives relatively close in to the inner solar system, as well as one that's a longer period comet on its way in. Already, the first sample, you never know what you're going to find in advance. The Wilt 2 sample from Stardust that was returned in 2006 already not only was glycine, and there were some other surprises about the kinds of dust particles in the comet and so on, the Tron particles and other types, but there were high temperature silicates found in this thing. And this is a comet that was out a long way from the sun for most all of its life. So this was an indication that early in the history of the solar system, there had to be an enormous amount of mixing, fairly violent mixing, going on to get these high-temperature silicate minerals out so far away from the sun. That was a huge surprise already from just a sample of one object, and so you never know what you're going to find. And so I would think you'd want to try to sample a number of different kinds of comets as far as where they've spent most of their time.
One thing I find interesting to think about in terms of my career is in the last 30 years that I've been doing comet observations, we've learned a lot about the origin of short-period comets versus long-period comets. We used to think, say in the 80s and before, that all the comets came from the Oort cloud. And the short-period comets are a subset of the long-period comets that were captured from their really highly eccentric orbits from the outer solar system. And the numbers never worked. And there were a lot of problems with that original model. And in the late 80s and early 90s, it became, well, because the models didn't work by factors of tens or more, some of the modelers were starting to suggest that maybe there's another source of short-period comets that is different from the long-period comets. And shortly after that, in the early 90s, the Kuiper belt was discovered, which, by the way, I would have called the Fernandez belt after Julio Fernandez, who actually had a model that suggested maybe there was some debris out beyond Neptune that would feed the short-period comets that we see. And the centaurs are an intermediate population of objects that are working their way in from the Kuiper belt, and some of those become the short-period comets we see most likely. And after we learned all of this in the last 30 years, we realized that the long-period comets that come from the Oort cloud, that have their most distant place in their orbit is on the fringes of the solar system, just barely bound to the sun. These things probably actually formed closer to the sun than the short-period comets, which we see closer to the sun today. And the short-period comets probably formed in the Kuiper belt out beyond the area where Neptune is right now. The planets were formed around the same time. The planets ejected all these objects out into the Oort cloud, the stuff that was actually forming around the planets, while the stuff that was out beyond Neptune wasn't being kicked out very quickly, and remained stable for the age of the solar system until it slowly evolved into a planet-crossing orbit, and then eventually came down to become Comet P. Scotty 1 or something like that. I think that's really almost ironic that the comets that we see closest to the sun came from, originally were formed in the early solar system farther from the sun than the stuff that we see that's been living on the fringes of the solar system that we see in the Oort cloud and the long-period comets. It's really fun to talk about.
So migration has worked in more than one direction here.
Yep. Kick them out and then bring them back in occasionally. Yeah.
And of course, there was talk about the planets being affected by migration too.
Yes, definitely. We've seen. We had to explain what we know as the late heavy bombardment, where the moon, in particular, we've seen saturated with impacts that happened something like 3.8 billion years ago, in a very short window, maybe 200 million years long at most. Where there was a quiet period before that, where the impact rate was relatively low, and then suddenly, bam, the whole solar system is saturated with these impacts, and then afterwards we go back to sort of a calm, quiet solar system, relatively speaking. And planet migration is apparently very important in that, because the Jupiter and Saturn would essentially were shifting themselves. They sort of do a dance where they tug on each other a little bit. And as Jupiter and Saturn interacted with this disk of debris, the asteroids and comets, some of which we still see today, they slowly moved and rearranged themselves. And there's even one idea that Uranus and Neptune actually formed backwards, where Neptune formed closer to the sun than Uranus did. And during this whole process, did a dance of some sort to put them out far away from the sun and in backwards compared to where they were originally in distance from the sun. But in the process, they went through all this planetesimal disk that threw it all over the place and caused the late heavy bombardment. And in the process, probably ejected a lot of comets out to the outer solar system and things like that, too. So it's fun to listen to my friends who work on the formation of the solar system. It's a little bit like listening to cosmologists talking about the formation of the universe. And I always get a little chuckle when I watch them a little closely, arm waving about what happened 4.5 billion years ago, compared to the cosmologists talking about what happened 13.72 billion years ago. So fun to listen to anyway.
Now, do you believe, I know a lot of people say that a lot of the water on Earth came from cometary impacts. Now, I know that CG and Rosetta haven't given us a distinct answer on this. In fact, the answer so far from the results that have been published have said no. But do you think this is actually remotely possible?
Well,
I think. Okay, go ahead.
Oh, I'm sorry. I was just going to say, and I looked into this a lot in writing the book that I wrote for Cambridge, and maybe Jim can update me because I'm sure he probably knows more recently than I do. But as I understand it, the whole assumption that, well, there were lots and lots of comets slamming into Earth, and they're 80% water ice, and Earth has a lot of water on it. A whole lot compared to our distance from the sun of what a planet might have. It was sort of a foregone conclusion for about 20 years there without, but the hydrogen to deuterium ratios, the DH ratios don't stack up very well with comets compared to the what's it called? The Vienna mean ocean standard here for Earth. So, as I understand it, the latest sort of thinking was that maybe about 10 to 15% of the water in Earth's oceans came from comets, but an enormous amount of water came from icy asteroids. And also, oddly enough, a lot of reading that I did, and this came from some of the University of Arizona publications, that you can get a lot of water molecules even in a hot early solar system adhering to the grains that accreted into proto-Earth, the planetesimal that became Earth. So as I understand it, the sort of latest thinking is that some water in Earth's oceans came from comets, but not a lot or most, as it was sort of assumed for a long time. But Jim, maybe you know more recent information than I do.
I think you probably hit the nail on the head there. In the old days, it was recognized that the deuterium ratios weren't matching for the comets we saw compared to the ocean. And I think as time has gone on, we've discovered, almost been surprised at, that asteroids often contain water. Ceres has some water locked up in its rocks that we've seen. And I think a lot of the other asteroids also have water that is left over from their original formation. And I think the original solar nebula probably had a lot more water closer to the sun than we gave it credit for. And I think that's probably what you basically said that exactly. And I agree that's probably pretty much what the story is here with our oceans and oceans on any other worlds when we find them.
So, what do you feel is the next step in for cometary science, as far as moving forwards to new horizons, if you'll pardon the pun?
First of all, I'd like to discover another comet or 2 or 10, but that's another story. I think we're going to continue to see comets up close and asteroids up close and be able to compare them in ways that we haven't been able to in the past. And I think we'll understand their dynamics a little bit better and understand about where they've come from, where they've been all this time, and where they may have formed in the first place. We just need to find more comets, I guess, and observe the ones we know about better.
And let's try and lay this particular one at that. Do you feel that comets are a threat to life on Earth? I know there's a lot of people out there, they're going on about the near-Earth objects, so let's try and put this one to rest and put people's minds at ease, if possible.
Yeah, being a worker in that field, the hazard of near-Earth asteroids, my day job or night job is trying to observe and discover and then observe and refine the orbits of near-Earth asteroids that might come close to the Earth. And I think comparing the numbers of long-period and short-period comets versus asteroids, the ratio of comet to asteroid impacts are about a factor of 10 or something like that. So for every comet impact, there are about 10 asteroid impacts. So it is fairly small likelihood. However, over the course of my career, we've discovered more than 10,000 near-Earth asteroids, and by we I mean all my friends, and I've discovered a few, 300 or 400 of them. What we're going to do is we're going to find all of the dangerous asteroids, and we'll know about them. We'll know where they are, where they're going for the next 100 or 1,000 years, and so we'll know if any of those might pose a future hazard to life on the Earth. The problem with comets is they come out of the boonies. You have, if you're lucky, Hale Bopp, we had about a year or so warning from the time it was discovered inbound until it might have hit the Earth had it been on an Earth collision orbit. And that's probably going to continue to be the case for a long time until we could have surveys that can detect very, very faint objects very, very far away from the sun. And then when you detect them, these things are comets, I remind you. And comets have non-gravitational forces. And you might perfectly characterize the path of the comet when it's out by Neptune, yet several years later, as the sun starts heating it up and it starts outgassing and jetting, it's going to push itself from a near miss to an impact, and you won't know which way it's going, or from an impact to a near miss. And I don't know how you're going to know how to figure that out without assuming that it's going to hit, even though the likelihood might be 1 in a billion. So that's going to be a continuing problem, even when we can find them out beyond Neptune, inbound 10, 20 years out. You're going to have so many false alarms that, yeah.
Right, and although comets, it's unlikely a comet would produce a global catastrophe, although Hale Bopp, the largest cometary nucleus known, was a 60-kilometer object, and that's why it became bright so early and stayed bright so long. But most comets, of course, are 1 kilometer or smaller objects. They're, and they're compositionally, of course, mostly ice. They don't do you any favors if you're locally right where the comet hits. Then you got to it ruins your whole week right there. But I actually, for the Asteroid Day folk, looked into this because there was a lot of arm waving going on with all sorts of stuff and people saying, oh, it's not really a danger at all, or it's a terrible danger. So I spent a few weeks a month ago, sort of more or less a month ago, looking into this and got the best numbers that Paul Chodas and Don Yeomans and Al Harris at JPL and Mark Boslow and others all agree on. And from the asteroid standpoint, there's going to be, on average, a 1 kilometer asteroid that will impact Earth. Now, averages are averages, mind you. 2 of them can hit relatively close together and then a long time pass, before another one. But the average strike of a 1 kilometer asteroid on Earth is about every 700,000 years. Now, you've got about 1 billion years left on Earth, humanity, if we don't manage to wipe ourselves out in another way, until the sun boils the oceans off of Earth, and then it's the end of life on Earth. That's a lot of 1 kilometer asteroids striking Earth potentially in the next 1 billion years. So it's not an imaginary problem to think. It may not happen for a very long time, but it's not an imaginary, completely exaggerated problem. It's a problem that will happen again in the history of Earth.
course,
I definitely agree. The advantage we have is that we're observing them all. We will, in the next few decades, have discovered every kilometer-sized asteroid there is out in the asteroid belt that might eventually become an Earth impactor, and we'll be ready for them decades or centuries ahead of time. The comets, I go back to my earlier statement, they come out of nowhere. We can't see them until it's almost too late. And even though they might be kilometer-sized objects, they're coming in much faster than an asteroid will. They might be more fragile, but I think they are a lot of rock as well as ice. I think that the ice is actually
still deliver
but they still hit
they
you.
Still
and they
deliver
still
an enormous amount of energy. Though.
Yeah, definitely.
Yeah.
Well, of course, the one everybody remembers is Tunguska in Siberia. I probably pronounced that wrong.
Tunguska, yes.
Thank you very much. I do apologise. Yes, and that was an airburst, wasn't it? It wasn't actually a physical impact. It was. They think it was now an airburst.
It was an airburst,
and it was a wake-up call, really, even back then. But nobody really recognised it for what it was. So, do you think we'll see more of the airburst type? I know Chelyabinsk was slightly different, but it was still, again, it's an airburster. And that one was completely under the radar. No one expected that one either.
We'll definitely see those, and there's been a little bit of argument still going on between a couple of different groups as to whether Tunguska might have been a cometary nucleus or an asteroid, but Chris Chiba and lots of other people showed that, with the velocities that you're talking about, you can have an airburst and completely lose the main mass of an asteroid. There's so much energy involved in flattening the object there. So it's not entirely clear whether that was an asteroid or a comet. I think it's leaned back toward asteroid. Correct me if I'm wrong, Jim, in recent months and years. But these events will definitely happen again.
Yeah, they happen all the time. A Tunguska-sized event happens probably every few centuries, and the one happened just 100 years ago is not just a lucky coincidence. It is a regular event. Most of the time, it'll hit over the ocean or over relatively uninhabited land, but occasionally it'll hit someone or close enough to hurt someone. Chelyabinsk, for example, didn't kill anyone. But one thing we learned is if you see a bright fireball in the sky overhead, get away from your windows because the shock wave from the blast is going to shatter windows and could kill you if a shard of glass hits you in the wrong place. So they may happen fairly often, and they're not terribly dangerous, but not completely safe either. So those little guys happen all the time. As you get smaller and smaller, they become events that happen on monthly time scales that produce really nice fireballs and maybe some meteorites on the ground wherever they come in. And the Earth is our solar system is a very, very busy place and a fun place to be, although not a very safe place to live.
Well, I know they used to say that Jupiter had two faces. Either it was the vacuum cleaner of the solar system, or it was like the lobbing. It used to lob the stuff at us directly.
It's both.
Yeah.
It's both.
It's both.
In the early days, it cleared out the solar system in the early days. If Jupiter hadn't been there, the impact rate on the Earth might be something like 1,000 times higher than it is today. But because it was out there, it cleared most of the debris away. Now, at the same time, it's still out there, and it's shaking up the debris, and it's feeding impacts now. So it's both our savior because it cleared out the debris to begin with, and now it's our tormentor because it's feeding debris in to hit us. So you can't have it both ways, I guess.
Do you both think we're going to get another Shoemaker-Levy 9 style event? On the level, say, not just an individual spot on the Jovian atmosphere, but say something 2 or 3 or more fragments hitting?
I don't know how often that actually happens. We may have been really, really lucky. The fact that one of the world's experts on impacts in the solar system was one of the co-discoverers, and Gene Shoemaker. After all, he proved that that meteor crater was an actual impact event, rather than just being lucky about having meteorites nearby this big hole in the ground that a lot of people thought was a volcanic event instead of an impact. And he was there and was part of the discovery team for the first time we ever got to predict and watch a planetary impact happen. I don't know, like I said, I'm not sure how often those happen, but Shoemaker-Levy 9, we believe, got captured into orbit around Jupiter, possibly in the 1930s, and had been roaming around Jupiter in a very loose orbit, having its orbit perturbed by the sun and, to a lesser extent, other planets, but mostly the sun, as Jupiter went around the sun. And it eventually became Jupiter impacting. Now, if there's a source of objects like the progenitor of Shoemaker-Levy 9 that are orbiting the sun or even orbiting Jupiter even today in loosely bound orbits that could be changed to impacting orbits, then it might happen more often than we expect. I haven't heard anyone estimate how often these events ought to be happening on Jupiter, where they are a moderately sized object that is big enough to be tidally disrupted and then potentially hit the planet itself as well. Those are two different problems, really. And I hope we get to see more of them, but I don't expect them to happen in my lifetime anyway.
I agree. I think we...
Go on, David.
Oh, I'm sorry. I was just going to say I think we can't really know, but I certainly hope we see another one, because I had a Celestron 8 out in my backyard just near my house, and to see that, and to see the scar after scar and the planet rotate, I mean, that was a magical, amazing event, and there was nothing at all that we've had anything like that in the past or really since, even though there were some little individual impact discoveries. So I really hope that we have another event like that, because it was electrifying.
I agree. I remember watching that. I went to Israel to try to observe the impacts or side effects of the impacts. I was hoping to detect the little nuclei as they got really close to Jupiter and maybe broke up further as they just before hitting. We weren't sure what they would do. And I remember being so disappointed because I didn't get to see anything. We were there. The very first impact was going to be visible from where I was at, and we saw nothing. There were some amateur observers who thought they might have seen a flash, but I don't know if they saw anything or not. But afterwards, I was sitting around being very disappointed in not having seen anything. I wasn't able to get the observations I wanted, and so then I checked my email. And I heard about what they were seeing with the Hubble Space Telescope, and my night was was greatly improved. But one other thing, I remember a colleague who was bold enough to publish a little note basically saying that it was going to be the big fizzle. He didn't expect anything to be observable on the surface. He didn't expect anyone to see flashes off the moons like some of us hoped to see. And he put it in paper and in print. And about 2 months later, we watched in amazement as Shoemaker-Levy 9 plowed into Jupiter and created these huge plumes and dark spots and everything. That was just so exciting to see, and it certainly uplifting after doing so much work and so on, observing the object. Really a great time to be part of astronomy there.
Now, you both knew Eugene Shoemaker. What do you think he would have made of Rosetta?
No, I think he would have been excited to see it happen. Yeah, watching what was going on there, and probably saying "I told you so" or "Oh, I didn't think about that." Probably in adjacent sentences.
Agree, and I'm sure Carolyn is very excited seeing all the images now as well.
Neil?
There's one thing I've got to ask Jim about, because I saw Jim on a documentary, I don't know if it's National Geographic or Discovery, but we were talking. They were talking about the periodic comet 2010 A2 Linear. I don't know if you remember that one, Jim.
Yeah, I'm trying to remember. I don't remember the details of it offhand.
It's the main belt comet that was. It had the nucleus that was seen to show shape of a cross.
Oh, okay. Yeah, that one.
And
okay.
Yeah, I just wondered because has anything else been said about that one? Because at the time it was even you sort of like were on the TV, sort of like, well, we just don't know what this is. Was that followed up at all?
I can't think of any new results, but it seems to me that was probably most likely an impact event on the surface, and that X pattern and everything was just the result of the splash of debris off of an asteroid impact. Asteroids, after all, run into each other. Real tiny stuff will hit the bigger stuff all the time, and occasionally we'll maybe get to see it. But there are apparently potentially active comets out in the main belt, and I don't know how many of them might be the result of impact, maybe exposing some ice that for many orbits afterwards might become active when it's close to the sun, or how many times maybe, like I said earlier, we're discovering a lot more water amongst the asteroids, and a lot of it may produce comet-like activity that we see in some of the asteroidal comets, if you will. It's very hard to get a comet into an asteroid orbit and make it behave like a comet after that, but it's easier to imagine that maybe there are sources of ice and water and other volatiles that could make an asteroid look like a comet from time to time. So I still would have to say we don't really know the answer for sure, but I think it behaved more like an asteroid impact event, and the debris flying off of it producing what we did see that made it look like a comet.
Anything else, Neil?
No, I wondered about David and Jim's thoughts about Comet 17P Holmes back in 2007, the big outburst. Do you think anything hit that, or do you think it was a pocket of gas that just blew a huge chunk of the nucleus apart, or just wonder what their thoughts were?
Well, we just are taking a look at Comet Churyumov-Gerasimenko, CG, or whatever you want to call it, 67P, and it has what to me looks like a binary nucleus, like two pieces that are probably relatively lightly glued together. And you can imagine a comet might have something like that going on, and pieces fall off of it, or maybe something opens up. I'm not sure whether this binary nature of 67P is due to erosion of stuff around that neck area that exposed it and made it look like a neck, or whether it's two solid pieces that are just lightly gently resting against each other and have been that way for 4.5 billion years and are maybe on the verge of falling apart. It would be fun to watch as the comet goes through perihelion to see if the structure of the comet changes in any significant way. One thing we know about comets is they do really interesting things. They have outbursts like 17P. They break up like Comet Mach-Holtz from a decade or so ago. They misbehave. You get used to seeing a comet come around the sun and do a very specific sort of type of behavior, and then suddenly it goes blah, like 17P Holmes did a few years ago. And I think it's doing it right now as well. It's brighter than it had been at previous returns at the present time as well. So like they misbehave and do it's like having kids, they get into trouble and play with the dog food or whatever they do, or whether you want them to or not. So,
and these may be some these may be some episodes of what Whipple used to call cometary fading, of how comets die eventually through some of these episodes. And remember that asteroids and comets, we think of them as these solid blocks and of 1 kilometer diameter or 5 kilometers or whatever. But many of them may be rubble piles that are sort of loosely held together gravitationally, and all kinds of fun things can happen when you've got all sorts of areas exposed to radiation, rather than having one big, solid, nice, well-behaving chunk.
Yeah, totally agree. That I think we've moved away from the consider a spherical cow mode, where you assume that it's a uniformly structured object that's this little sphere, and we've realized with asteroids as well as comets that they are much more complicated objects that slowly accreted from different kinds of objects that orbited around at the same time. And it's not just a very simple thing. These things are complex structures that might have layers of ice or ice buried in the surface that suddenly becomes exposed and makes the comet much more active, and then maybe goes away for a while and it becomes very quiet for a while, and then maybe another layer gets exposed or another little nodule gets exposed, and it becomes active again. And that's, I think, what makes the comet so fun to observe.
Well, gentlemen, we've actually been on this for 1 hour 13 minutes already, and it's been a really great conversation. And I know that you're both very busy people, so I'm going to suggest that for this particular show, we say thank you very much. Would you guys be willing to come back again?
Oh, of course.
Definitely, yes.
That's brilliant. Now, as I say, I just want to thank David and Jim for coming tonight. It's been a really great chance to have a chat with you guys, and I'm looking forward to doing another show with you. And Neil, it's been quite a great...
Oh, it's been absolutely brilliant.
Yeah, we've had...
it's been brilliant, yeah.
We spoke to Alan Hale earlier today, and now we've got David and Jim on the phone with us as well. What more can you ask? And it's going to be quite interesting to get some of the feedback from the comet watching community when we get the show out on astronomy.fm. So I'm going to say thank you very much, guys. It's been a pleasure having you here, and great.